What's up? What's up? What's up? What's up? Welcome to Yebo Tutor Livestream. Help! It's been quite some time. Who do we have? Come on in on this beautiful Monday. I know you guys are on holiday, you are chilling out there, but let's just look at some few problems on functions. Now we are preparing our way to go to our June exams. So share with friends, share with family. It's about to go down. It's about to go down. So today we'll be doing functions. And I'm hoping that we'll be able to assist each other. If it's your first time to be with us, please do like, share, and subscribe. And also in the description of this video, feel free to join the WhatsApp group. You can either text the number which is attached, or you can use the link so that you can join our WhatsApp group. On our WhatsApp group, we share important information to all the students. So it's very important and it's very crucial that you join our WhatsApp group so that you can receive the material. So basically, as we are still waiting for others to join us, on functions, we have 4 or 5 graphs which we were taught from our grade 8 till to grade 12. I believe that all of you guys have covered already the functions. So the first one, we were taught about the straight line function, which is a equation y equal to ax plus b. It's a straight line, so the gradient can either be positive or negative, which means that your graph can either be an increasing function or a decreasing function. Then we were taught about a parabola, which is either smiling or it's angry. It's like so those kind of stuff are so important. And on our parabola, we know that we have to calculate the turning point of the graph. We must also be able to calculate the x-intercept as well as the y-intercept of the graph and be able to analyze the graph. And moving forward from these two, now we were also introduced to a hyperbolic function. So a hyperbola, it's a great function because it's so easy. So it's always y equal to a over a minus p, sorry, a over x minus p plus q, where x and q are the asymptote of the function. So I prepared questions which have parabola, straight lines, hyperbola. Then we have the other one, which is called the exponential function, which is also a graph which has an asymptote. And the last one, which is the inverse functions, which you are taught in grade 12. Then now you're introduced to things like what's this the log function, how to use log. So without wasting much time, let's dig into what we are doing today. So I checked the question paper, so we'll be doing a question from Gauteng. I hope you guys are all ready. So this is a paper 1 for the June exam paper. So here is our question number 4. Here is our question number 4. So let's read it together. Let's go. Let's write it down. So we are now on question number 4. Let's use red so that everyone can see that there is danger. The graphs of f of x equal to x plus p squared plus q and g of x equal to a over x plus b plus c are drawn in the sketch below. We are told that we have two functions, f of x. We can see that f of x is a parabola for the fact that it's equal to x plus p squared plus q. That's a turning point formula. Then g of x is equal to a over x plus b plus c. That one is a hyperbolic function. So these are our graphs, and we are given a point A, which is 5 over 2 is to 0. And this point is the x-intercept of the function of f of x. And we are also told that P is a turning point. So the turning point of the function of f of x is located at P, definitely we already know the x coordinates that is going to be 1 is to y. Why? Because we can see that the asymptote is 1. Now we are given the vertical asymptote passes through 1 is to 0. Okay, great. We are already seeing that. Then the horizontal asymptote passes through 0 is to 2. Definitely we also see that. So it's so important to know and analyze your graph before you answer any question. So we already know that our horizontal asymptote y equal to 2, then our vertical asymptote x is equal to 1. Now, without wasting much of the time, let's look what the questions want. Show that the equation of g can be written as y equal to 2 x minus 1 plus 2. That's straightforward. So 4.1. Let's do 4.1, guys. Let's do 4.1. Let's show them that we know what we are up against. So on 4.1, what is important is to understand that we are given the function of g of x, which is equal to a over x plus b plus q. Yes. So now we are also given that we have a horizontal asymptote, which is equal to 0 is to 2. Then we have a vertical asymptote, which is equal to 1 is to 0. That's what we are given. I'm sorry, guys. I'm bit feverish, but I'll manage properly. So we are given this, and we already know, guys, this is straightforward. By now, I think everyone should be able to know that Q is equal to the horizontal asymptote, and x plus b will be equal to that vertical asymptote 1. Then you solve for b, then your b will be equal to it's gonna be uh, x minus 1. So definitely now we can actually see that our value of x of b is negative 1. Bear in mind that, guys, we are doing this because if it's a positive value, which means here it's gonna be negative. So already we have y equal to a over x minus 1 plus 2 because we have substituted the asymptotes of all the graphs. So from that point now, guys, this is not hard. We know already that from this point we can now solve the problem. So let's solve the problem, guys, together. So we are also given the x-axis. We can see that the function of g of x, which is the hyperbola, it has a point there at 0 is to 0. So we substitute point 0 is to 0 because that's both the intersection of the x and the y intercept. So 0 is equal to a over 0 minus 1 plus 2 negative 2 equal to a over negative 1. We cross multiply, then a is equal to positive 2. Therefore, y is equal to 2 over x minus 1 plus 2. Then you have your 3 marks. You're out. You are out already. You have passed already. You have a distinction already. Now, we are told to calculate the coordinates of P. What is P? We know that P is the turning point of, let's write it like this. So P is the turning point of f of x. Okay, and we can see that P has the same x value as the vertical asymptote. So definitely now we already know that P is x is, sorry, it's x is to y. Then we know that P is 1 is to 0 because it has the same x coordinate. So it's 1 is to y, sorry, since we don't know only the y. Now we should be able to calculate the coordinates of P. How can we do that? So we know that f of x is equal to x. Let's look again. So we're given f of x to be x plus p squared plus q. Okay, so this is what we are only given. So now let's solve. We have a point a on this function, guys. So this makes everything so easy for us. Okay, so since we know the point That's already giving us a hint. Okay, so everything now is now looking good, is now looking promising for us. So f of x, so we say we have a point also a, which is 5 over 2 is to 0. So let's start by substituting a 5 over 2 is to 0 in f of x. So this will be 0 is equal to 5 over 2 plus p squared plus the value of q. But we already know, guys, that our p is 1 is to y. So definitely we can say substituting that point p is going to be 5 over 2. Since it's positive, when we plug it here, it's going to be negative 1 squared plus the value of q, so that we can get q. Then we just use our calculator. Then we get 0 is equal to 9 over 4 plus q. Then q will be equal to negative 9 over 4. So we can see that the turning point will be p 1 is to negative 9 over 4. Just like that, you are happy, I am also happy. So what is important is to understand that given this function here, it's given in the turning point form. So the value of the turning point will be negative p is to q. So what do? We see that p is having the same x coordinate as the vertical asymptote. So we can see that now already we have the value here, which is negative 1, which is positive 1. So when we plug this value in the original, it's going to be x minus 1. Then after that, everything will be history, because we also see that we have a point A, which is also in our graph. So we can just substitute that point A in the function of f of x, so that we can have the value of q. Then we calculate q, then our q is equal to negative 9 over 4. Therefore tp is equal to negative 1 is to negative 9 over 4. Then we are good to go. We are good to go now. Let's proceed, guys. Any question, feel free to ask your questions. I'm also on the group. Please ask your question if you have any question. Okay, seems like we are still good. Let's proceed. Write down the equation of the vertical asymptote of p if p of x is now gx minus 1. So what will be our value there? This is easy, guys, because now we're on 4.3. Initially, g of x is equal to 2 over x minus 1 plus 2. Now it has been horizontally shifted with 1 unit to the right. So now where there is x, we put x minus 1 plus 2, which is equal to 2 over x minus 2 plus 2. Then therefore our vertical asymptote is x equal to 2, because we take what is here, we equate to 0, then we solve for x. Then we have our vertical asymptote. You see, functions are so easy, guys. Determine the equations of axis of geometry of G in the form y equal to mx plus c if m is less than 0. So they are telling us m is less than, which means it's a negative gradient. So this is easy, guys, because we already know what is our function of g of x. So on 4.4, g of x is equal to 2 over x minus 1 plus 2. Now we want to calculate the axis of symmetry. So the axis of symmetry is always here. Let me use this. It's always here. So this is the axis of symmetry. Yes. So if it's now the negative 1, this is also easy, because we know that now it's going to be, let's write it down. It's going to be y equal to negative x minus 1 plus 2. So we just add a negative sign in front, then we can calculate the function. So y equal to negative x plus 1 plus 2, then y equal to negative x plus 3. So this will be our axis of symmetry. So if they said where m is greater than 0, so you were just gonna say y equal to x minus 1 plus 2, then y is equal to x plus 1. So this is for m greater than 0. M is the gradient, guys. As always, it doesn't change. It always have the same value. Now on 4.5, let's go. Write down the equation of k if k is the reflection of g about the x-axis. So again, g of x now, which is equal to 2 over x minus 1 plus 2, it has been reflected along the x-axis, which means the whole graph will change. So we are multiplying the whole graph by -1 since it has been reflected upon or about the x-axis. So now we have our equation of k. Let's just say k of x is equal to -2 over x minus 1 minus 2. So this is our new function for which values of x is f prime of x times g of x greater than 0. What is f prime of x? According to your calculus, f prime of x is the derivative of the function. That's the derivative of the function. So now we should be able to know where can we see the multiplication of the derivative of the function and g of x, where are they greater than 0, which means where are both functions negative or both functions positive. So that is the key note on that part. So guys, it's not hard. It's not hard at all. It's not hard at all. Sorry, guys, it was just a technical glitch, but we are proceeding now. So, how can we determine where these two? This is easy, guys, because we know that f prime of x is the gradient of the function, and g of x is just the function of g of x. So, where are they both positive? So, we can see that when it's 4.6, when x is greater than 1, can see that both functions are positive. Then also when x is less than 0, when x is greater than 0 or less than 1, we can see that as well. From 0 to 1, we can see that these two functions, they are both negative. So as I was saying, that you just have to be able to know what is greater than 0. Greater than 0 is supposed to give you positive. So if you multiply these two functions, where can you find their gradients positive or both negative, so that they can certify what you're supposed to calculate? Now on 4.7, this is nice, guys. Functions are so nice. For which values of k will the equation g of x equal to x plus k have two real roots of opposite signs? Where can we have this? We can see that when the k value is greater than 0, we can see that when k is greater than 0, then we have two roots of opposite signs. You can see that when it's greater than 0, which means starting from here, going this direction, guys, we can see that it we have two roots of opposite sides. You can see that we have two here, and we also have two here, which are below, which are negative. So this is also easy and straightforward. Let's go to question 5. Question 5. What do we have there? What do we have? Somebody talk to me. Also looking on our WhatsApp group, we are still clear. Seems like we are still good. All of us, we are cruising together. No one has asked any questions so far. So let's proceed there. And if that's the case, let's proceed there. Let's proceed if that's the case. Now, let's do question five, guys. Let's do question five. Time is not on our side. 1 mark, 1 minute, 2 marks, 2 minutes. Now, question five. The graph of h of x is equal to ax. So we are given the graph of h of x, which is equal to a of x. So what do we know about that graph? We can see that h of x is equal to ax. This is an exponential function automatically. Where a is greater than 0, yes, we can see because the function is above the x-axis. So that's not really hard. Then we are also given the point P, which is, so we are given P, which is -1 is to 1 over 2. Definitely they will say, what is the equation of h of x? Or maybe they will say, what is the coordinates of q? I'm just thinking out loud. So it's very important to know the function's characteristics and know how to apply those different characteristics of a function. Oh, wow. Write down the coordinates of Q, guys. This is so easy because we already know the coordinates of Q. It's like I was propheting. So always, guys, know how to apply, how to solve a problem by just looking at it and solving the problem. So 5.1, the coordinates of Q, it's just easy, guys. It's raised to 1. Someone is asking, how did you just see that? So we can see that Q is a y-intercept, so x will be 0 and it will be y. So if we substitute Q 0 is to y in h of x, then y will be equal to a to the power 0, and anything to the power 0 is equal to 1. So that's why q is 0 is to 1. Just like that. Those things, collect these marks. Collect. These marks are easy marks for you guys to get. Now, write down the equation or determine the value of a. How can you determine the value of a, guys? So I think you can have two options. So we have y equal to uh, ax, then we substitute point p, which is -1 is to 1 over 2. So where there is x, we put -1. Where is y, we put 1 over 2. So 1 over 2 is equal to a to the power -1. Then solve for a using your skills which you have been taught already. So you can see 1 over 2 is the same as 1 over a. Then a is equal to 2. Just like that, because you cross multiply and make a the subject of the formula. 5.3. What do they want? Functions are so nice, guys. Call in your friends and share with your friends and tell them that functions are cool. They are so nice. Write down the equation of h inverse in the form y. So this is easy because now we know that h of x is equal to 2 to the power of x. Then y equal to 2 to the power of x. So step number 1, in order for you to determine the inverse function, you swap x and y, then you solve for y. Then therefore y equal to log 2 of x. This is the inverse function of h of x. This is easy. First step, you swap. Second step, what do? You solve for y. Just like that, you are happy. Now, sketch the graphs in your answer book. Wow, let's sketch them, guys. Here it is. My lines are not straight, but yours, I know they will be definitely straight because we will use our ruler and everything will be straightforward and accurate. So that won't be a big problem after all. That won't be a problem at all. So now let's move forward. We have -1 here is to 1 over 2. -1 is to 1 over 2, which is point P. Then we have Q here, which is 0 is to 1. Then we plot our function. Here we go. Oh, sorry. Let's go. everywhere we go. We can see that from negative infinity to positive infinity. Then when we say plot the inverse function, in other words, it has been reflected along the y equal to x. So we can plot the reflection. So this one was q0 is to 1. So now q inverse will be 1 is to 0. So we are just swapping the values. If this one was x, now this one will be y value. So this won't be that much hectic. So now we have 1 is to 0. Then this one was negative 1 is to 1 over 2. So negative 1 over 2. Negative 1 now is on the y and 1 over 2 is on the x. So it's a point which is somewhere here. Then we can plot our graph. So this is the graph of h inverse of x, and this is h of x. Happily ever after. So these are our functions. We plotted them with love. And yes, here we are. Okay, now let's move on to the next problem. Let's move on to the, it's not many questions, guys. We're just going through functions in a few period of time. Okay, now write down the domain of h inverse. So guys, this is how the inverse functions work. So the domain of h of x is the range of the inverse function, and the range of the inverse function is the domain of the h inverse. So we know that the domain of in this instance we must look at the range for the original function. Sorry, the range of h of x is y must be greater than 0. So which means also the domain will be x should be greater than 0, just like that. So x, let's use red. So we are on 5.5. So we say x must be greater than 0. Next question. Hence or otherwise determine the values of x for which log 2 of x is greater than 1. Wow, this is easy. Where is the value of x in the inverse function greater than 1? They are greater than 1 for every x greater than 2. We can see that from our graphs. If g of x is equal to 100 times 3 of x, calculate the value of x for which h of x is equal to g of x. So in other words, these graphs, they are intersecting. So h of x is equal to g of x. What is our h of x? It's 2 to the power x equal to, what is this one? It's 100 times 3 to the power x. Now they say calculate. This is a bit tricky, but this is what we do. 2x over 3x is equal to 100, guys. Equal to 100. Then we know that 2 over 3 to the power of x, okay, because we are just applying the log is equal to 100. Then we can just apply the log. Now x will be log 2 over 3 times 100. That will be the value of x. So let's use our calculator to get the value of x. So that will be the value of x, guys, because we just applied our skills in solving exponents and our skills in solving log equations. So what will be the answer? So the answer will be easy, guys. The answer will be only, with our calculators, negative 11,36, because we must always round off to the nearest two decimal places. So we saw that h of x is equal to g of x. Then after that we saw that 2 to the power of x is equal to 100 times 3x. Then we divided both sides by 3x. then 2x to the power divided by 3 to the power x equal to 100. Then we made x, as we can see, to be on top. Then everything was good and super good. So our x value will be equal to negative 11 comma 36. Now let's go. Where are we now? Where are we? Where are we? Let's look at problem. Oh, we actually done 12 marks collected. So 12 plus 14, that's 26. Wow. So guys, if you didn't know, functions have plus or minus 35 in your paper one. You're already almost level 1, so don't worry guys, just understand it. Sorry, use the graph to determine the values of x for which f of x is greater or equal to negative 1. This is so easy guys, because you can solve it. So it's question 6. You can solve it, or you can just show it fast. So 6.1, use the graph, so we know that f of x should be greater or equal to negative 9. What is our f of x? F of x is negative root 27 multiplied by x. So they're saying it's greater or equal to negative 9. So from this point, we know that we have square root of 27x greater or equal to 9. Then we square both sides to remove this. So we have x greater equal to 9 squared. It's 81. But now this is a big number, or as they say, where x is f of x is greater or equal to negative 1. So definitely we did something here which is not right. So let's look at it again. So use the graph to determine the values of x for which f of x is greater or equal to negative 9. So, oh, we're actually right. Sorry for canceling. We're actually right, because it was only supposed to be 27x greater or equal to 81. Then we divide by 27, divide by 27, then x will be greater or equal to 9. Here goes 3 times 9, here goes 9, 9, 9. Then we can see that x must be greater or equal to 3. But we can also see that from 0 to 3, also the values of x are located there. So it's 0 less or equal to x less or equal to 3. So guys, if you are slow like me and you don't understand how to get the answer directly, I would advise that you just substitute in the original equation here after you have done everything. Now you start from 0 and check if you substitute 0 here, are you gonna get a number which is greater or less than negative 9? Then you can see the range that it should be between 0 and 3. Then you get your 2 marks. Then you write down the equation of the inverse function. This is easy guys. We know that y equal to negative 27 of x. Okay, then we swap. The steps don't change because of how ugly the problem is. Then we solve for x, so we divide by negative 1, so it's now negative x equal to uh, root of 27 y. Then we square both sides, then x squared is equal to uh, 27 y. Then we divide by 27, we divide by 27, then y is equal to x squared divided by 27. So we can actually see that. Indicate all restrictions. Oh, okay. So for x less or equal to 0, then here it's x greater or equal to 0, then here it's y greater or equal to 0. So the restrictions, you can just include them. They are not really hectic. On the other problem, sketch the graph. So the graph is going to be the inverse of the one we already have. So the same way we plotted the other graph is the same way we will plot this one. This one is like this, then it will be reflected here. We had a point here which is 3 is to negative 9. So here we're gonna have a point, -9 is to 3. So it's somewhere here. So we're just gonna draw the function something like this. So this is f inverse, this is our original function, this is -9 is to 3. So we just swap the coordinates and plot the function. The last question of the day: describe the transformation from F to G, which led us to have this. Oh, this is great because this is the reflection in the x-axis. Why? Because when we reflect a graph along the x-axis, we multiply the whole function by -1. So when we multiply negative root 27 of x times -1, then we get positive. So that's why we have, so it was just reflected in the x-axis. That's what I had prepared for you guys. Hoping to see you this week, Friday. I'm gonna stream again so that we can perfect our functions. Okay, so please do tune in on this week's session on Friday. Have a great time. Don't forget to study as much as you're on holiday. Prepare for your exams as well. Have a great evening. Thank you so much for tuning in.